Good morning, everyone. This is Divion Tutorials. So today we're talking about chemical bond. We say chemical bonding deals with the various attractive force joining chemical species together. So let's just say this now that atoms hardly exist on its own. For instance, you can hardly see hydrogen atom just on its own. You can hardly see chlorine just on its own, except maybe in the lab. But most time you see them in your normal day-to-day activities. For instance, you see salt. Salt is the combination of sodium and chloride, so you see them every day. So that is chemical bond. Chemical bond is the force of attraction between two chemical species. Chemical species means atom, molecules, compound, and the likes. So atoms, the reason why atoms combine is to form duplet or octet stability. So what is duplet? What does it mean to be duplet stable? Duplet stable means having two electrons in the outer shell. In the first outer shell, there's something we call KLMN. The first one is 1, 2, 3, 4. So the maximum number of electrons that can stay here is what? 1. So how do we get it? You do 2 open bracket 1 square. 1 square is what? 1. 1 times 2, 2. So the maximum number of electrons that can stay in this first shell is 2. So once you have that 2 shell, duplet means you know now 2 stable. Then another one is octet stable. The second one is L. Once you put 2 inside here, 2 raised to power 2 is 4. 4 times 2, 8. So the number of electrons that is supposed to be here is 8. So once you have that 8, is octet stable. So I'm saying atoms react or combine because they either want to be duplet stable or octet stable. So duplet stable and octet stable is the goal of every chemical combination. Take note of that. Then noble gases do not combine easily because they are already stable. For instance, helium has this configuration, neon has this configuration, so they don't need to combine to be octet stable. They're already octet stable. Then I think I've said this before. Okay, no, atoms combine with their valence electrons. Let's say valence electrons, I said electrons in the most outer shell. Let's look at this. This compound is what? Sodium. Sodium has how many electrons? 11. How do we know that? I think in the former video I told you guys that the number of electrons is the number of what? Atom is the atomic number. So the atomic number of sodium is 11. It means it has 11 electrons. So how will you draw it? I told you the first one, the highest number you can have is 2. 2. The next one, the highest number you can have is 8. 2 plus 8, 10. You will now draw another one with what? 1 electron. This 1 electron is the most outer shell. This most outer shell is what we call valence electron. So it is this valence electron used to combine. Hope I'm making sense. So types of bond, we have 2 types of bond: interatomic or intramolecular bond and intermolecular bond. Interatomic means within different atoms. You know it when they say interethnic marriage, intraethnic marriage. So this one means within different what? Atoms. So let's just say hydrogen and oxygen atom. Then this one means between molecules. So this is where we have van der Waals forces, hydrogen bond, and the likes. So let's go straight to interatomic bond. So interatomic bond, we have either ionic bond, covalent bond, or coordinate covalent bond. So let's start with ionic bond. Ionic bond is also called electrovalent bond. I said they are formed between two kinds of metal having a large electronegative difference, so 1.7 or greater. What am I trying to say? If two atoms combine together and the electronegative difference is 1.7 or greater, it is an ionic bond that is in that compound. So this ionic bond is usually found between metals and non-metals. And to include, you see the way I make this capitalized, it involves transfer of electron from metal to non-metal. So let me give you an example. So this is sodium. I've drawn it before. I told you this is the first shell can only take maximum of 2, that is duplex stability. This one can take maximum of 8, octet stability. So 2 plus 8 is 10. To make this one 11. So how did I get 11? I'm telling you again that the atomic number is the number of electron, right? So the atomic number of sodium is 11. That's why we have 11 electrons. This is for sodium. So sodium has 1 valence electron. I say valence electron is the electron in the most outer shell. So let's come to chlorine. Chlorine has how many electrons? 17, because the atomic number of chlorine is 17. So 2 plus 8, 10. 10 plus 7. So this one have 7. So remember, I said the goal of every chemical reaction is to achieve octet or duplex stability. So this one now, it has 1. So for it to become octet stable, it has to give either 7. It has to either give this one or it receives 7. So between giving 1 and receiving 7, which one is easier? Giving 1. It can easily give 1. Once it give 1, this shell will go away. It will not remain this one. This one will be what? Octet stable. Then you check out this one too. This one have 7. So for it to become octet stable, it's either it give out the whole 7 or it accepts 1. So which one is easier? Accepting 1. So this one that is here will now leave this sodium and come and meet this chlorine. Remember, this chlorine is 7. Once that chlorine, you transfer it from here to here, it will become what? 8. So this one will be what? Octet stable, 8. Let's say this one will go away. It will not remain this one 8. Then this one too will also be what? Octet stable, 8. So both of them will be happy and they will form sodium chloride. And the electronegative difference is what? 2.1. And I said a ionic bond has the electronegative difference of 1.7 above. So let me give you another example you can explain. This is your daddy, for example. This is your mommy. So both of them, you know, your daddy will transfer semen to your mommy. She will accept it, and both of them will be happy, and they will form a compound. That compound is what? U. So you can see it involves transfer. Take note, it involves transfer. Then characteristics of, or the same thing. Let me give another example. This is a typical Nigeria boy, Nigeria girl. Nigeria boy will give his money to the girl and be happy. Mumu boy give his time to the girl and be happy. So the girl will be collecting it. Both of them will be happy, allegedly. So characteristics of ionic bond: it has high boiling and melting points, soluble in polar substance like water, conduct electricity in multiform. That means NaCl can be what? Electrolytes. Then their reactions are very fast. So let's go to covalent bond. Covalent bond involves sharing that are formed between 2 or more atoms having 0 or very small electronegative difference lesser than 1.7. Remember, electrovalent compound are 1.7 or greater. So it exists in molecules of non-metals. Yeah, so for homonuclear molecules, when the bonding atoms are of the same kind, the electronegative difference is 0. So the covalent bond between homonuclear molecules is what? 0, and it is called what? Non-polar covalent bond. So what does this mean? It means the same atom. For instance, you can see here, see the example I use. Hydrogen and hydrogen are the same atoms. So let me explain what they mean by sharing. Hydrogen has only 1 electron. Hydrogen has 1 electron, but for both of them to be stable, remember, stable electron must have 2. So this one will now come say, I have 1, or I have 1, bring your 1. This one will now bring the 1. This one too will bring the 1. So both of them will now have 2. That 2 that both of them have, they will be sharing it. That is covalent bond. So for this kind of covalent bond of the same atom, it is what? Non-polar covalent bond. Why? The electronegative difference is 0. And non-polar covalent bond has the electronegative difference of 0 to 0.4. I think I've written it here. Okay. So for heteronuclear molecules, where the electronegative difference is between 0.5 and 1.7, they'll be what? Polar covalent bond. See it. polar covalent bond 0.5 to 1.7. So let's give another example of a polar covalent bond. Heteronuclear means between atoms of different compounds. For instance, hydrogen, oxygen, and hydrogen are different compounds. So an hydrogen has how many electron? 8. How do we know that? From the atomic number. So 2 is first stay here. 8 minus 2, it will be what? 6 that is here. 2, 4, 5, 6. So for it to be stable, it needs 2 extra to become 8. So this hydrogen has 1, this hydrogen has 1. So this hydrogen that have 1 will bring this one and come and share with this one. So both of them here will have 2. Their hydrogen and oxygen here will be sharing 2. This hydrogen here too will come here and bring this one. So both of them will be sharing 2. So that's how we now have like this H2O water. So water is a polar covalent bond. So let's go to coordinate covalent bond. It is also called dative bond. Coordinate covalent bond is a special kind of covalent bond. But this one, you know this one, see the difference. Both of them will bring. This one will bring. This one will bring. They will not share it. But in coordinate covalent bond, only one person will bring and the two will share it. So let me explain this one. Me and my best friend Kennedy want to go somewhere and they ask us to bring our share. So Kennedy brought 2 share and me I forget my share. So when I now reach that place, I wanted to sit down. So instead of me to go back, Kennedy now say, take my own share. I brought 2, you take 1, let me take 1. So both of us will sit down comfortably. So let me explain with chemical compound now. This is ammonia. So ammonia, let me first explain. This is nitrogen. Nitrogen has what? 5 at valence electron. That means electrons in the outer part. So for it to be balanced, there's something we have here. Hydrogen will combine with this one. This is what we do. One hydrogen will come and join this one. The two of them will share this one. Do you understand? The hydrogen and the nitrogen will share this one. Another hydrogen will come here. Two of them will share this one. Another hydrogen will come here. So by the time you notice, 2, 2, 2 is already octet stable. If you notice, it's already octet stable. Hydrogen is sharing with this one. Hydrogen is sharing with this one. Hydrogen is sharing with this one. It has 8 electrons, but if you notice, this electron is free. It's not sharing with anybody. So this electron that is free is like that my friend that have 2 seats. It now come hydrogen plus. Hydrogen plus is hydrogen in on. It has no electrons. Yes, because it is only 1 minus 0 that will give you 1. We have talked on this topic before, so you can go back and watch our video on our previous videos. So it has no electron. So when it has no electron, that one will now call it. This one that is free now say come. This one will say I have no electron. You say don't worry, just come and join me. I have electron that is enough for you and enough for me. So both of it will come here. Both of them will now share this one. That is what how we get NH4 plus ammonium ion. That is what we call what coordinate covalent or dative bonding. So metallic bond also exists between metals and ions. For instance, if you see your ion, they contain metallic bonds. So metallic bond is favored by large atomic radius, take note, low ionization energy, large number of neutrons in valence shell. Then we have intermolecular bond. The first one is van der Waals forces. I said van der Waals forces are weak attractive forces between non-polar and polar molecules. They also exist, I'm trying to make this clear, okay, they exist between layers of graphite. What is graphite? Graphite is an atom of carbon. So if you notice all the videos we have done on chemistry before, it always keep repeating. So that is one thing about chemistry. Learn everything because it will be useful in the next videos. Then van der Waals forces is the weakest kind of force in among this intermolecular force. Then van der Waals forces can be divided into 2: London dispersion force and dipole attraction. Out of these 2, the weakest one is what? London dispersion force. So London dispersion force is the weakest force. Is the weakest of the weakest force. So it's still the weakest force. Then hydrogen bonds are special dipole attractions between a polar molecule. Take note, hydrogen bonds only occur in polar molecules. and it is formed when hydrogen reacts with oxygen, nitrogen, or fluorine. These three are very electronegative elements. So another thing you need to know is that hydrogen bond is responsible for the high boiling point in its compound. For instance, like water, some chemical compound like alkanol and the likes. So once you see oxygen hydrogen bond in a chemical compound, notice that once an organic compound has hydrogen bond, the compound will surely have high boiling point. So if it has two hydrogen bonds, it will have higher boiling point. So this is Divion Tutorials. To join our free classes, just message me on WhatsApp 09153177154. Thank you.